back. In this class, we're going to talk about the Group 1 reactivity. So these are the elements that are found in Group 1 of the periodic table. What do you need to be able to do? So for the exam, there's not a whole lot the examiner can ask you here. Number one, you need to be able to describe and explain the reactivity as you go down the group in Group 1. So does the reactivity increase or decrease? Why? Number two, you need to be able to write equations for the reactions of Group 1 metals with three different things, such as water, oxygen, and hydrochloric acid. Now, if you can write these balanced equations for one element, you can write them for all of the ones in Group 1. It doesn't matter what it is. So let's start off with the reactivity of Group 1 and describing what happens to it. Well, first of all, it would be a good idea to ask yourself, how do Group 1 elements form bonds? How do they actually react? The Group 1 elements react by, how do they form bonds? So they are metals. They have one electron in their outer energy level. How do they get to a stable outer octet? They lose an electron. So all of the elements in Group 1, all of the metals in Group 1, they will react by losing one electron. Now, the easier it is for that element to lose one electron, the more reactive it is going to be. So this ties in really nicely with electronegativity and ionization energy that we studied previously in the trends topic. So for lithium, lithium's electron that would be removed when it reacts is here in n is equal to 2. When you move down to sodium, the electron that's removed when it reacts is in n is equal to 3, and potassium's is in n is equal to 4. So as you go down the group, the electron that's being removed when that element reacts is in a different energy level. Your electron is moving further and further and further and further away from the nucleus. That means it's going to get easier to remove that electron. So as you go down the group, it's easier to remove the electron, therefore the elements get more and more reactive. So as we move down Group 1, our elements in Group 1 are lithium, sodium, potassium, cesium, rubidium, whatever else. So as we move down the group, the reactivity increases. 3 marks for saying the reactivity increases down the group. Now, this type of a question hasn't been asked since 2019, so make sure you know this one. Reactivity increases down the group, 3. Now, why does it get easier to remove that electron as you go down the group? Number 1, your atomic radius increases as you go down the group, meaning the electron that you are removing is further and further and further away from the nucleus, so it's less attracted to the nucleus. And number 2, as you go down the group, you have an increase in shielding by the inner electrons. And that's it. So that is your explanation. Now, it's really important here that you recognize that the Group 1 elements react by losing an electron. Because if you understand that that electron is going to leave the metal and go somewhere else, the easier it is for the metal to give up that electron, well then the more reactive it's going to be and the more likely it is to give up that electron. So the electron is going off somewhere. So this is all based on attraction of the nucleus for that bonding electron. Your atomic radius increases, you have an increase in shielding. You could also say technically as you go down the group, your ionization energy decreases, but it wouldn't be my favorite. I'd go for one of those two because you've already learned that phrase in relation to the summary table and electronegativity and ionization energy previously. So now use those exact same 2 bullet points and make it work for you here so that you can still get your full 6 marks in explaining the reactivity of your Group 1 metals. Okay, so we've moved back to the other board. Now here we're going to go through the 3 types of reactions you have to be able to write balanced equations for Group 1. Group 1 metals are quite reactive. They react with oxygen. Now for this particular balanced equation, you have to be able to write the equation for all of the Group 1s with oxygen. We're not going to learn all 5 separate balanced equations. If you can give this, what happens in this reaction in words, you'll be able to write the equation for any of these Group 1s reacting with oxygen. Now here, the word equation that we're going to learn The group 1 metal, whatever the group 1 metal is, it could be lithium, it could be sodium, it could be potassium, whatever else. That reacts with oxygen to form a metal oxide. Okay? Now, start off with one of the group metals. We're going to go with lithium. So we're going to take lithium and react it with oxygen. Now, when those two react together, you form the metal oxide. So the metal is lithium. So it's lithium oxide. Now, to write this balanced equation, lithium is an element, and it's a metal, so it has the symbol Li. Oxygen, elemental oxygen, is O2. Now, to write the equation or the formula for lithium oxide, lithium is in group 1, it has a +1 charge. Oxygen is in group 6, it has a -2 charge. You have a +1 and a -2. +1 minus 2 does not equal to 0. So we go by the lowest common multiple method that we saw in bonding. So for the lowest common multiple, you have 1 and 2, the lowest common multiple is 2. 1 goes into 2 twice. So for lithium oxide, I have Li2. 2 goes into 2 once with 1 oxygen. Now, for this equation, you have 3 marks in your exam. 1 for the lithium, 1 for the oxygen, and 1 for the lithium oxide. But we're not balanced. We haven't got the same number of atoms of each element on each side. So I have 1 lithium on the left, 2 lithiums on the right. I need to put a 2 in front of the lithium to balance. Then by doing that, I'm still not finished. So I've balanced my lithiums, but now my oxygens need to be balanced. I need to have something in front of here that multiplies it by 2 to get 1. And that is a half. Now my equation is balanced, but if you were writing the same equation for the reaction of sodium plus oxygen to give me sodium oxide, again, you would need a half oxygen and a 2 sodium. If it was cesium, it's cesium plus oxygen to give me cesium oxide, a half, and 2. So if you can write the balanced equation for one of them, just swap out the metal and then you can do it for all of them. It's quite a vigorous reaction, so be able to write that one. Now, the most important one that you have to be able to write is this one. Now, hopefully you saw this one in the lab where your teacher cut off a little bit of the 3 of the group 1 metals, threw it into a basin of water, and we saw lots of nice bubbling, and wasn't it brilliant? Now here, the word equation for this is your group 1 metal reacts with water and we form 2 products. You form a salt, which is, you form your group 1 metal plus water. You actually form a base, which will be a metal hydroxide. So we have metal hydroxide plus hydrogen gas. Now we're giving off a gas in this reaction. So the hydrogen, you will see that being given off as little bubbles or fizzing or effervescence. Very common question is, what do you see when this reaction has happened? Bubble, fizzing, effervescence. Any of those 3 gets you 3 marks. Now let's pick one of our metals. Let's go for sodium. Sodium reacts with water, which is H2O, to give me sodium hydroxide. Now, if you're not sure of how to write your formula, it's Na plus and OH minus. +1 minus 1 is 0, so you need 1 of each. That will give me sodium hydroxide plus hydrogen gas, which is H2. Now, that is 4 marks out of 6 for that balanced equation. 1 for each of the correct formulas. Now, to balance, 1 sodium on each side, sodium is fine. Oxygen, 1 on each side, it's fine. Hydrogen, you've 2 on the left, but I have 3 on the right. Don't touch the sodium hydroxide. I'm going to put something in front of the H2. I'm going to put a half in front there. A half times 2 is 1, plus 1 is 2. Now we have balanced that equation. The last time this came up, they were asked to write the balanced equation for francium reacting with water. So francium reacts with H2O to give me francium hydroxide plus a half H2. If I wanted rubidium plus water to give me rubidium hydroxide plus a half H2. So learn it for sodium and then the rest of them will all fall in line. Just swap out the sodium for whatever the other group 1 metal is. How do you test for the presence of hydrogen? Well, you collect a sample of the gas. and then you add a lit splint and you hear a squeaky pop. Another thing would be, how do you know you're forming a base here? So from your acid-base chemistry, you add an indicator into the basin of water, and as the metal is reacting with the water, it's floating across the surface of the water, you will see a trail of blue behind, if you use universal indicator, behind the metal as the base is being formed, because the base is dissolving in the water as it's formed, and it's changing the pH of the water, making it more basic or alkali. So that's why it will change colour in an indicator. Right, for my last reaction, we have the reaction with our group 1 and hydrochloric acid. So here, this is a very, very, very dangerous reaction. And it should never be carried out in the lab because of how vigorous the reaction is. So the word equation, my group 1 metal, it reacts with hydrochloric acid. Now, when this reaction happens, it looks fairly innocuous because you'll look at it and go, that can't be that dangerous. How dangerous is my salt? So we will form a salt, which is the metal from group 1, combining with the chloride from the hydrochloric acid. So we have a metal chloride plus hydrogen. Now again, hydrogen gas, it's a gas. So when it's being produced, you'll see fizzing or bubbling. Now for this, my group 1 metal, if I start with sodium, react it with HCl, we form the metal chloride, which is sodium chloride, NaCl, and hydrogen gas has the formula H2. Now that's not balanced, my hydrogens are out, so I'm just going to put a half in front of the H2. You can put a 2 in front of everything else and a 1 in front of the H2, it's the same balancing. If I wanted to do the same for francium, francium reacts with HCl to form francium chloride plus a half H2, lithium plus HCl to give me lithium chloride plus a half H2. This reaction should never be carried out in the lab because it's so vigorous. You produce hydrogen gas so rapidly that it actually will explode the container that it's in. This is a very explosive reaction. So in your notes, highlight the word explosive. And that's why we shouldn't carry it out in the lab, because it's going to explode the container that you've done the reaction in. Right, that's it for the group 1s. So be able to tell me how they react. They react by losing 1 electron. Describe the reactivity down the group. It increases down the group. Why? Your atomic radius increase in shielding, so it's easier to get that electron off of the atom. And then write your balanced equations for group 1 elements with water, oxygen, and hydrochloric acid. And that's all the examiner can ask you here.